Find the Laplace transform of t times e to the 2t times cosine of 5t. So we're going to first use this property where Laplace of e to the at, where a is any constant number, is multiplied by f of t, any function dependent on independent variable t. For us, let's let this be f of t, and you can simply ignore t and leave it out in the front. And from this table property, that'll equal f of s minus a. So for our case, we have e to the positive 2t, where e is raised to the power of 2t, a equals 2. And multiplying that by our f of t, which is the cosine function, this will become f of s minus a, which is s minus 2. That means when we take our Laplace transform of our f of t, cosine of 5t, wherever s appears, we replace that with s minus 2. So, Laplace of cosine of, let's say, bt, where b is any constant, equals s over s squared plus b squared. And we know b equals 5, as there is a coefficient of 5. So, therefore, Laplace of cosine of 5t should equal s over s squared plus 25, or you can leave that as 5 squared. Now remember, this is f of s. We need to convert it to f of s minus 2. So over here on the left, let's say f of s minus 2 now equals our s on the numerator becomes s minus 2, and this s squared on the denominator becomes s minus 2 squared plus 5 squared, or 25. Now there's one last property we need to use. We still need to address this t out in the coefficient. For our final property, we know the Laplace transform of t to the n times any function f of t will become negative 1 to the power of n, where n is any constant, and nth many derivatives of f with respect to s. Since n equals 1, because t is t to the power of 1, this will become, let me write here, n equals 1. This will become negative 1 to the power of 1, and the first derivative of our function f with respect to s, or just simply negative df ds. And remember, we're not acting this on f of s, but rather f of s minus 2, since we have the e to negative 2t times this whole cosine transform. So this will become negative d ds of our f of s minus 2. S minus 2 over s minus 2 squared plus 25. Unfortunately, this will be a derivative of a fraction, so we know that d of ds of f over g should give you gf prime minus fg prime over g squared. Of course, all with respect to s. With our known numerators and denominators, don't forget to leave out the negative in the front. You take g, the denominator, and put it out on the top without any derivative. So s minus 2 squared plus 25. And then you multiply by f prime. So the derivative of s minus 2 with respect to s is just 1. Then minus f, which is s minus 2, times g prime, which is the derivative of the denominator. And I'll probably expand that down here, where we know s minus 2 squared equals s squared minus 4s plus 4, and don't forget that plus 25. So that becomes s squared minus 4s plus 29. Now taking the derivative of that with respect to s should yield you 2s minus 4. And the 29 is a constant, so it goes to 0. And don't forget, we are putting that all over g squared, which you could just say is s squared minus 4s plus 29, all squared. Let's do some simplifying, and before we apply the negative, we can address these negatives up here. So negative s minus 2 squared plus 25 minus 2s squared minus 4s minus 4s again, plus 8 over our denominator. So this becomes s squared minus 4s plus 29. That was this part up here. And let's apply the negative to all these terms, while simultaneously simplifying. So minus 2s squared. This would be minus 8s, but put a negative in front, so plus 8s minus 8. And this equals s squared minus 2s squared is, of course, negative s squared, minus 4s plus 8s is positive 4s, and 29 minus 8 is positive 21. And once we distribute the negative sign, that gives us our final answer of s squared minus 4s minus 21 over s squared minus 4s plus 29 squared. For more free solutions, please like and subscribe, and I'll see you in the next one.